the GitHub repo for this project is shown on the slide here. And yeah, as I said, it's an open source, distributed Python SQL engine, pretty similar to SparkSQL in terms of functionality right now, that I'm doing as part of my PhD research. So yeah, so brief introduction. What is Quokka or Quokka? So yeah, I believe many people here are familiar with Presto or Trino or SparkSQL, and there are newer alternatives like Modin or Polars that all offer, like data frame API or Dask, right? Offer data frame API, but a lot faster than pandas because they can use multiple cores on the same machine or maybe multiple machines in a cluster. So yeah, Quokka is basically that. It's yet another distributed data frame library, except everything is in Python. So this makes it different from Presto, Trino, SparkSQL, which are all based on the JVM and stuff. So Quokka is also fault tolerant. So this makes it different from Polars or Dask or Presto or Trino, meaning that it can recover in the middle of a query if you're using spot instances and one of them happened to get unplugged by AWS. So Quokka supports data frame API with pretty strong SQL flavor right now. You can do arbitrary filters with SQL statements, etc., etc. And I guess the most interesting thing about Quokka and why I'm presenting at the PyData Global Conference is actually just to make a point that how easy it is to build something like this with the amazing tools that we already have in the open source Python community. For example, Quokka is completely built on top of open source Python projects like Ray, Apache Arrow, and Polars. I also use Redis and the Redis Python client to do the coordination. So how Quokka works is that there is a Ray coordinator that spawns a bunch of Ray workers. If you guys are not familiar with Ray, I strongly encourage you to check it out. Ray and it's the company that formed around it, Anyscale, are really doing a good job making it really easy to do distributed computation and spin up different workers on the cloud as well as locally. And so the Ray coordinator spins up a bunch of Ray workers, which are basically actors that have some state and can do functions. And yeah, so I use Apache Arrow and Polars, which I believe there are also some talks about at PyData Global here, which is a new, really fast, single machine data frame or SQL library written by Richie. That has really come out in the past couple of years as the fastest way to execute data frame operations locally. So yeah, so Quokka uses Polars library on single machines as well as Apache Arrow to shuffle data across these Ray workers. So now that basically we have single node Ray worker executors that can execute data frame expressions really quickly, and we have a coordinator with a Redis global store to store some global control state about this application. We can chop up, a data frame execution plan into many different pieces, dispatch them to these Polars workers running locally. And yeah, you have a distributed Python-based data frame system. So I guess another way to think about what Quokka is maybe distributed Polars. Like if you take Polars locally and you try to make it distributed and use multiple machines, this is what you'd get. So a few notes about Quokka's performance. I mostly compared it on like some TPCH queries, which is industry standard SQL benchmark, TP3, and using Parquet file input starting from AWS S3, which is cloud storage that is really cheap. And I compared it to Trino, which is formerly known as Presto SQL, which is probably the industry standard way of running SQL analytics on cloud storage these days, as well as SparkSQL, which is also a really popular solution. We see that Quokka is a bit slower than Trino, but quite a bit faster than SparkSQL for most of these queries. And it's important to note here that Trino does not support the fault-tolerant semantics that Quokka and SparkSQL support, which means it cannot recover if one of the machines in your cluster dies. For example, if you're using spot instances or something like that. So yeah, so should you use Quokka today, right? As I stated in the beginning of my talk, there are many other alternatives today that you can use, like SparkSQL and Trino, obviously, as well as Modin, Dask, and maybe even just pollers on a single machine if your data set size is not huge. I mean, first, if you're curious about this, you should definitely talk to me and email me at this email address right here. Happy to discuss Quokka as well as why I built it in the first place and where I'm taking it next. There are a few reasons why you might want to use something like Quokka today. So, for example, if your workflow is like really UDF heavy, is a lot of user-defined functions, and but somehow Spark cannot support it because of the poor Java to Python interface or something, then you could explore something like Quokka. Now, if your workflow is pure SQL, and like fault recovery doesn't really matter, there are solutions like Trino and StarRocks, which is, I believe, commercialized now as Seller Data or something, that will solve your problem a lot better. And if your workflow is like UDF heavy, but reliability is very important, and you don't really care about speed, and you want to go with some established solution, then I think you should stay with Spark. Otherwise, you have some workflow that is taking a lot of time, has a lot of UDFs, maybe you could try Quokka. And I'm definitely happy to make it work for your use case. So you can contact me here. And yeah, so I guess finally I want to just a couple of notes about what I'm going to do next. So I mean, I built Quokka as an intermediate tool to support several use cases related to recommendation systems, especially given I used to work in finance and other cases where you want to predict things that will happen next given historical features. So I will be building some future projects on top of Quokka that have to do with like terabyte scale time series analytics, such as of joins, window joins, range joins, point in time joins, all the kind of joins with time series information where good SQL engines don't typically support that well. And also, I'll be building some backtesting and feature backfilling features on top of Quokka. So if you define some feature definition based on SQL and you want to compute what that value of the feature is at a point in time in the past, and you want to do that across all of history, that is a bit difficult right now. And yeah, so I'm going to try to do that in Quokka next as well. But so in conclusion, Quokka is this Python-based SQL and data frame library built on top of these really amazing open source Python frameworks. And the core of it is really only just 1,000, 2,000 lines of code compared to the code base for SparkSQL, which is, I believe, 30,000 lines of Java or something. It really goes to show the strengths of the open source Python ecosystem. And it's a big reason why I'm presenting it at this conference. And happy to interact on GitHub or send me an email if you have any questions. And yeah, thank you.